Scientists have just discovered something completely crazy under the ice of Greenland. The world's largest island behaves completely differently than previously thought, and GPS stations scattered across the Arctic have now revealed the secret of the Ice Age.
Stay tuned to find out what researchers have discovered using cutting-edge GPS technology, what lies dormant beneath the eternal ice, and why this discovery is so groundbreaking. A warm welcome, everyone.
This is what Greenland would look like without any ice. I don't know about you, but I could definitely imagine living in a nice little wooden cabin by the central lake. Let me know in the comments who would join me for an ice-cold Greenlandic barley juice. I'm curious to hear your thoughts. And I also wanted to tell you,
that was West Greenlandic. Sorry for my pronunciation. Translated, it means subscribe to the channel to stay well informed, because subscribing doesn't cost anything at all. You'll never miss a video again and you help out. And if you've already subscribed, giving the video a thumbs up really helps. Maybe we'll hit 5,000 likes. Thank you so much, everyone. And now let's head into the eternal ice.
Because what the scientists led by Daniel Longforsberg from the Technical University of Denmark have discovered sounds totally crazy. With the help of 58 GPS stations distributed across Greenland, they have discovered something that changes our understanding of the Earth. These GPS stations are part of the Greenland GNSS network, a monitoring system that has been measuring the movements of Greenland's subsoil with millimeter precision since the 1990s, and what they have measured is incredible. Greenland is drifting northwest at a rate of about 2 centimeters per year. That may not sound like much, but geologically speaking, it's significant. And this movement is not caused by current ice melt. No. The main driver is something that happened tens of thousands of years ago, the disappearance of the Laurentide Ice Sheet. During the last ice age, this Laurentide Ice Sheet covered almost all of North America. It was a mass of ice so enormous that it pushed the entire continent down. When the ice melted at the end of the Ice Age, North America slowly began to rise again. Greenland lies on the same tectonic plate as North America. Imagine pressing down on the middle of a trampoline and then letting go. The center bounces up, but the edges are pulled inward.
That's exactly what's happening with Greenland. It's being pulled closer to North America as if by an invisible magnet. And that's not all. At the same time, Greenland is also being deformed from within and
in opposite ways. In some areas, the island is being compressed, while in others it is being pulled apart. How does that work? The assumption was that Greenland is mainly being pulled apart by the recent ice melt, says Daniel Berg. To our surprise, however, we also found large areas where Greenland is contracting and shrinking. In some areas, the aftermath of the Ice Age still dominates. This causes the coasts to move toward the center and Greenland to shrink. In other areas, the effect of today's ice melt predominates. This causes ice masses to shift from the interior to the coast, creating an outward force that stretches the crust. Overall, this means that Greenland is becoming slightly smaller. At the moment, the effects inherited from the Ice Age are still prevailing, summarizes Daniel Berg. However, this does not necessarily have to remain the case, and perhaps the current ice melt will soon prevail.
These findings show that the Greenland ice sheet is much more unstable than we thought. About 10% of the world's fresh water is stored in this ice sheet, enough to raise sea levels by 7 meters if it were to melt. But before you panic and start buying floaties, even if this process were to begin, it would take centuries or even thousands of years. We're talking about geological timescales here, not something that happens overnight.
What is fascinating is that researchers were only able to measure all these movements with the help of state-of-the-art GPS technology. The 58 measuring stations of the GNet network work so precisely that they can detect movements of millimeters per year as if you were observing the movement of a hair on your head from space. Daniel Berg explains, we have created a model that shows movements over the long period from around 26,000 years ago to the present day. At the same time, we have used very precise measurements from the last 20 years to analyze current developments.
This research is also so important because it shows just how complex the systems of our planet really are. What happens today is often the result of processes that began tens of thousands of years ago, for example, during the Ice Age. The Earth has a long memory, and there is also a practical benefit.
The movements of the land masses are also crucial for surveying and navigation because even fixed reference points are slowly shifting, explains Berg. GPS coordinates are not as fixed as we thought. I find this discovery so exciting because it shows that our planet is a living, constantly changing system. What we consider immutable, such as the position of the world's largest island, is in fact in constant motion. Greenland is migrating, continents are drifting, and the Earth is continuously reshaping itself. I also find it particularly impressive that the researchers were able to precisely separate different influences, plate tectonics, the aftermath of the Ice Age, and today's ice melt.
It's a bit like a crime case where you have to figure out which suspect is responsible for which part of the crime. In any case, things remain exciting on the world's largest island. And by the way, here's a little fun fact.
Greenland is huge, but due to the Mercator projection, it looks much bigger on maps than it actually is. The further away from the equator, towards the south or north, the larger and more distorted countries appear on the Mercator projection. But it is simply the best way to depict a spherical planet on a 2D map. Germany also looks bigger on maps than it actually is. If it were located in the Arctic, the effect would be even stronger. Another extreme example is Russia, which is of course huge and the largest country in the world, but not as big as the map would have us believe. If we move Russia towards the equator, the whole thing is put into perspective.
If you don't want to miss out on exciting scientific discoveries like this in the future, don't forget to subscribe to the channel now and give us a thumbs up so we can reach 5,000 likes.
Away from the ice and toward the bubbling lava, the alert level in Italy at the Phlegraean Field supervolcano could soon rise. You can find everything about this in the video displayed at the top right. As always, you'll find another video about space and science at the bottom right. Otherwise, I'd say see you in the next video. Take care, everyone.